Newton's first law of motion states that an object will maintain its state of motion unless acted upon by an unbalanced force. This state of motion is called inertia, in which an object maintains a constant velocity and direction. In this example, a toy car moves because it is given an external push. However, due to friction and gravity acting upon it, the car is unable to maintain its velocity when moving and eventually stops.
Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object. This could be rearranged to a more familiar formula of force equals mass times acceleration. Now, this formula can also be tweaked and adapted to find the mass and acceleration as well.
Newton's third law of motion states that with an action there will be a reaction of the same amount of force in the opposite direction. This can be seen as the two cars are bumped into each other and they will go to opposite sides. All of Newton's laws of motion are present in everything that happens in our daily life as long as they have motion. For example, in any of our tests, actually all of the motions are present, however we only emphasize one or two of them that are highly highlighted. For example, in our example of the third law, both cars will keep on moving if there are no acting force upon them, meaning that this is one of the implementations of the first law. Also, both cars' force is also equal to the mass and acceleration that they have around in the bump, and that is the second law. This simple example means that all of the Newton's law are connected together. Free fall is when an object falls down with no external forces. Objects will fall with the same rate of acceleration regardless of their mass. Collision of objects with air particles is called air resistance, as the air resists the objects falling. These two forces, known as free fall and air resistance, will highly impact an object that is falling through mid-air. Free fall and air resistance implements the third law of motion. This is because of actually the force of air resistance is an example of action and reaction. The action of when an object or a product falls down, in which where the force of air resistance is the reaction. The reaction instead drags the object further up or slows it down, meaning that the time in which where it hits the ground because of gravity becomes slower. This is actually an implementation of the third law of motion, yet this application is done in a vertical axis, and whereas most application examples, such as the car example, is in a horizontal one. This is also one of the applications of the other Newton's laws of motions, however, the third one is highly emphasized here. Air resistance can also occur in objects that are moving horizontally. For example, when a car moves forward, the car's aerodynamic shape will actually help reduce air resistance as the shape seems to cut through air, meaning that there will be less air particles that hit the car and thus restraining it from moving faster. This is also a force made by the air that hinders the car from moving faster or accelerating. And therefore, air resistance is actually also present in horizontal axis as well. However, free fall is when an object falls down without any external force that applies upon it, and hence meaning that it only simply falls down.